So, couple products, or not products, properties I would like to introduce or re-discuss because they're very handy in this section involving radicals is that we have one property called the product property. And you can see my red pens dancing across the table. But anyway, the product property says that if we have a square root of two numbers being multiplied, we can split that multiplication up to a times the square root of b. Or we can work backwards. If we have two numbers being multiplied like this, we can combine them into one product. So don't always think you have to go this way. Properties work in different orders sometimes. Then we have what's called the quotient property. Which states the square root of a of this. I messed that up already. I'm getting ahead of myself. The square root of a divided by b. If we have division under one square root, we can separate that and divide it up to the square root of a over the square root of b, instead of doing it all in one radical. And likewise, you can work backwards on that. So, keeping that in mind, I just want to recap really quickly, real briefly, on simplifying square roots. So, example 1 is simplify, I'm going to abbreviate, simplify the expression. Oh, you can't see that. Expression. So, part A of this example, we'll say the square root of 24. Now, again, if you're not real clear on how to simplify radicals, see my simplifying radical video, and that will help you. You have to ask yourself, what times what makes 24, and 1 has to be a perfect square. And a perfect square is anything like 3 squared was 9, and the square root of 9 is 3. Anything that's a perfect square that can be taken the square root of and get a pretty number, basically. Is how that's defined. So, I know that the multiples of 24 are 6 and 2. Or what makes 24 6 and 2 are 4 and 6. I don't know what's up with my brain today, but 4 and 6 makes 24. And 4 is a perfect square because square root of 4 is 2. And square root of 6 cannot be simplified, so your answer is 2 6. Let's look at another one. Say we're given the square root of 6 times the square root of 15. Well, you remember the property that I introduced just a little bit earlier is called the product property, where I can combine these two into one radical. And I'm going to do that. So 16 times 15 is 90. And I have to go, okay, can I simplify this? And the answer is yes, because I can multiply this by one perfect square times another number. Not necessarily has to be a perfect square, but one has to at least be a perfect square. And that's 9 and 10. Square root of 9 is 3. And the square root of 10 is not perfect, but it's plus or minus. Not plus or minus. We're just simplifying. We're not solving. 3 radical 10. Sorry, I'm jumping ahead of myself today. And let's do one more. Actually, 2 more. So, say we have the square root of 7. This is all under one radical. square root of 7 over the square root of 16. Now, using the quotient property, I can break that up into the square root of 7 over the square root of 16. Square root of 7 doesn't simplify because there's nothing pretty that can make 7, so 7 stays the way it is. 16 could be changed into square root of 4, square root of 4, which are both perfect squares, which become 2 and 2, and you multiply those together to give you 4. And so that becomes square root of 7 over 4. And finally, the most important part of this first example is, suppose we have the square root of 7 over the square root of, not the square root, but square root of 7 over 2. Now looking at this, 7, like we learned from the previous example, is not a pretty number, and 2 is not a pretty number. But before I even go on that, I'm going to use the quotient property and split these guys up. So the square root of 7 over the square root of 2. This is fine the way it is, the 7, but it's not mathematically correct to have a radical in the denominator. So we must clear that. And the way we get radicals out of the denominator is called rationalizing the denominator. So what we do is we multiply the denominator by the same thing that's in the denominator. So radical 2 times radical 2. But what we do to the bottom, we must do to the top. And so this becomes 7 times 2, which is 14. And then 2 times 2, which is square root of 4, which then simplifies square root of 14. Square root of 4 is 2. And that will always, always, always get the radical out of there. Alright, now we're going to get into the main point of this lesson. We just had to do a little warm-up to get us thinking about radicals and how they work and all the fun stuff they do. So, let's do example 2. So say we have 2x squared plus 1 equals 17. Okay? Now, just like, linear algebra where you're solving for x and you got x by itself and got everything on the other side and x on one side and solve for it, same thing applies here, except this is squared. And the way we're going to figure out how to solve this here in a minute. But for right now, everything still applies. Everything's the same. We have to get this x by itself. So the way we do that, I'm going to subtract the 1 first. That's 2x squared equals 16 divided by 2. And then I'm left with x squared equals 8. Now the way to undo squaring operation is by taking the square root, hence the title for this lesson, solving quadratics by finding the square root. So when I take the square root of x squared, I get x. And when I take the square root of 8, I have to split it up into 4 and 2. Square root of 4 is 2 times square root of 2 plus or minus. Because I added this radical here, this wasn't given to us in the original expression, I have to count for both positive and negative. So that's what, instead of me writing out both factors, I take care of it with that symbol, plus over the negative. Let's look at another example. If we have 1/3 times x plus 5 squared equals 7. Now these are the types of, like the problems like the previous one, those are the easy ones for most people. But these tend to be a little more challenging or difficult, simply because people, A, there's a fraction, and people just don't like fractions, even though fractions are your friends, and B, x squared is not being squared. It's this you got to realize that this quantity is being squared. So just like you got everything away from x squared, you have to get everything from the quantity being squared. So this essentially is your variable for right now. And the fact that this is being squared and this is a quantity within a parentheses, you cannot just hack it off and get x by itself. You have to get everything away from this. So if it helps you to draw this box around it to remind you, you might want to do that. But I'm just going to erase that. So the first thing is, what I like to do is get rid of fractions. I mean, if you like dealing with a fraction and you want to go the long, I just lost my pen, but if you want to go the long route, you may. But make your job easy. If I multiply this by 3 over 1, multiply this by 3 over 1, this cancels with that, and this just gets multiplied. So I get x plus 5 quantity squared equals 3 times 7, which is 21. Now I can do my square rooting operation, because I have to get, in order for me to play with this guy or mess with this guy, I have to take the square root, because that will undo this operation here. So I take the square root, and when I do one side of the equation, I have to do the both sides. Then I'm left with x plus 5 equals the square root of 21. And simply, we have to get x by itself now. So if we subtract 5. And I'm left with x equals -5 plus or minus, because we add the square root, plus or minus the square root of 21, because 21 can't be simplified. And that is my final answer. Let's do a couple more. Let's go back to Easyville, and then we'll go back to one like we just did. So, I mean, if we're just given the equation x squared equals 90, all you have to do, I mean, x is by itself, there's no moving, you just have to take the square root of both sides. You get x equals plus or minus we have to first simplify that. It's 9 and 10, which is plus or minus 3 radical 10. So, I'm going to do one more example. If my pens would stop dancing across the table. We're going to do this one. 2 times x minus 3 squared equals 8. And again, this is my operation being squared, so I have to get everything away from it. And the only thing that I need to get away from it is this 2. So I'm going to divide by 2, both sides. I'm left with x minus 3 quantity squared equals 4. Take the square root. I get x minus 3 by itself, because this cancels that. Square root of 4 is 2, plus or minus, remember. I should add 3 to both sides, and I'm left with x equals 3 plus or minus 2. Because I can have 3 plus 2 or 3 minus 2. And that is the answer. So that's it, solving quadratic equations by finding the square roots. If you have any questions on that or any topics that you like to request, you can always email or comment, and I'll be happy to produce those for you. Thanks for watching, and see you around next time.